Great introduction. Yeah, I would have loved to have been there. I even had the opportunity. Daryl Gibb was going to drive me up to Saskatoon, and it would have been good to have some discussions with him as we are making the 7.5 hour trip. But unfortunately, can't make it. It's also, I got this thing set to record everything I say. So if I say something wrong, you guys will be able to see it and you can make note of it and correct me at the end of the presentation. So Gabriel wanted me to talk a bit about low bushel weight barley. Hopefully I can get the slides to switch here. There we go. Um, yeah, this is an area I did my PhD actually on the nature of cereal grain digestion in the rumens. So we did some work on this quite a long time ago, and we did some other work not too long ago, about 4 or 5 years ago, also looking at the effect of bushel weight and its value in terms of feed barley. So I just want to go through some introduction, a bit about grain structure, kernel anatomy, the importance of kernel uniformity and particle size distribution, how we adjust roller settings to optimize the utilization of grain, whether it be low bushel or high bushel weight. We've got some data too from a beef metabolism study that we ran a few years back. And then I'll just do a quick summary to give you the bottom line recommendations. So when we talk about feeding cereal grains, really doesn't matter what type of cereal grain we're feeding, whether it be barley, corn, sorghum, wheat. All of those grains grow out in the field and they develop resistant outer structures called the pericarp or the husk, which really have a chemical composition that resists microbial attack and digestion. So that's great when the plant is growing out in the field because it helps protect it against fungus and other pathogens that could potentially infect the grain. But it also causes problems when we feed the grains to the ruminant animal because those same structures resist degradation by the microbes that are inside the rumen that are needed in order to digest the grain. So we need to break down that outer husk or pericarp, and we do that through grain processing. And these are just some electron micrographs that I did during my PhD, actually, that show the outer surface of barley. And the only place that the microbes are able to attach and start to colonize is where that outer structure has been damaged. Once they gain access to the interior, then the microbes can readily attach and start to digest the starch that's there. The rate at which they digest that starch differs between cereal grains, with it being most rapid in wheat, followed by barley, and then by corn. And that's related to the chemical structure and the anatomy of the grain kernel itself as well. Those bacteria attach and they produce enzymes called amylases that start to break down the starch and release glucose. And that glucose is then fermented to the volatile fatty acids that is the major energy source used by the animal itself. So when you look at the grain structure, then you got that pericarp. Corn's a little bit different because the starch granules are more tightly bound to the protein in an area that we call the vitreous endosperm, where the bugs still have a hard time getting through that protein matrix to digest the starch granules. But when we look at barley, in the case of barley, the bacteria, once that husk and pericarp is broken, then the bacteria can get in, digest the endosperm cell walls, which are mainly made of beta-glucan, which are relatively easy for the bacteria in the rumen to digest. And then they can gain access to the starch granules and the protein. And both of those are more rapidly digestible than they are in corn. So then we end up with a need kind of for a balance because processing is going to be the major factor that's going to dictate the degree of value we can derive from the grain. So if we look at processing barley, then if we underprocess that barley, then there will be a lot of whole kernels, and the bacteria in that won't really be able to gain access to the interior of the endosperm to digest that starch. So that's a bad thing. If we overprocess it, so if we make it too fine, then we'll end up with very low ruminal pHs because that starch is fermented too rapidly and the acid concentration increases to too high levels within the rumen. That will result in the inhibition of fiber digestion. So any other fiber-based sources like hay or silage that we're adding to the diet, the digestibility of those will be reduced. And then we need to also balance that then so that the energy that's being released by the starch is matched by available protein that's in the diet, and that enhances microbial protein synthesis. So we want to make a balance between processing it enough to ensure the bacteria that can gain access to the interior, but not over processing it and generating too many fines to the extent that the digestion is too rapid and we can end up with acidosis. So it's a balancing act. Now, in order to try to achieve that balancing act, we have to make some sort of measurement. And we do that by measuring what we call the processing index. And all that is just weighing the grain in a set volume container before it's processed and getting a weight on it, and then processing the grain and collecting that same container full of that processed grain after that. And then by dividing the processed by the original grain and multiplying by 100, we get what we call a processing index. And the lower that processing index is, the more highly processed is the grain that we're looking at. So in beef cattle, when we've measured it in feedlots, we measure processing indexes anywhere from 72 to 90%. In dairy, it usually ranges somewhere between 65 to 70%. So you then end up with barley processed to different levels. So coarse, here's 82%. You can see there's quite a few whole kernels there yet. So under those conditions, that's under processed. You've got medium processed, so all of them are crimped. Medium fine at 70%. They're all crimped. Probably both medium and medium fine would work as suitable processing levels. When we get into fine at 65%, a processing index, at that level, we may have processed it too much, and that could then be susceptible to acidosis. Now, that's going to depend as well on what other factors are included in the diet, how much fiber, whether it be silage or hay or straw is included in the diet will affect what's considered a suitable processing index. Likewise, the chop length of that forage will have an impact on that as well. So when we look at then at digestibility, we can see that as the processing index becomes smaller, we get an increase in digestibility. So processing index of 74, then the digestibility of the diet was about 83%. The process index of where the grain was being fed whole, then you have a digestibility of only 60%. So that reflects the inability of those bacteria to gain access to the kernel and digestion. Now you look at average daily gain in feed efficiency, and you see that also has impacts, whereas when we are under processing the grain, then we have the lowest average daily gain and the poorest feed efficiency. But interestingly enough, when you look at where we've maximized the processing and we've got maximum digestibility, we also have a reduction in both the average daily gain and in the feed efficiency compared to when it was processed to an index of 82%. And we would propose that that's probably as a result of an increase in the incidence of acidosis. So you've got high digestibility, but you're still having performance issues because the animals are experiencing more incidences of acidotic conditions. So that then just reflects that differences that we see in feed to gain and overall performance as a result of those changes in digestibility. So those are all basic concepts that are related to grain processing, and they apply equally to regardless of the type of grain that you're feeding. But one of the disadvantages of using processing index is it doesn't really always consider particle size. So if you've got proper rolling here and you generate uniform particles, then that mixed material or processed material may have a processing index of 74. In this case, all the particles are of a similar size, so they're going to be digested at a similar rate within the rumen. But if you've got a mixture or pour rolling, and you end up with a mixture of large and small particles, then your processing index may still be 74. But in this case, this material is not going to be digested as in as an efficient a manner because the small particles are going to be digested too rapidly, and the large particles may not be digested enough. So even though you've got the same processing index, you're not looking at the differences between these two fractions based on particle size and the value that it may have for the animal itself. Now, we can use different processes to help reduce the degree of variability in the size. If we look at whole barley, and then we look at the differences in particle size as a result of processing, you can see we get a distribution there across the various sizes. If we temper roll the barley by adding moisture, then we reduce that degree of variability and more of the barley stays in a larger particle size, 2.36, where we've got sufficient processing for the bacteria to digest the grain, but not too intensive of processing that we end up with a lot of fines that's going to contribute to that acidosis. So that's really the advantage of temper rolling over dry rolling, is that tempering gives you greater control over maintaining that particle size within a proper distribution. Now, one of the things that comes up is with regard to changes in kernel weight and variability in kernel structure, and what impact does variety have on that? So we looked at variability in kernel volume weight over a number of years, and the factors that may influence that. So when we see these changes in bushel weight, then it may be related to blending. So you may have it where during grain handling, lightweight barley is being blended with heavyweight barley to create a barley with a higher average overall bushel weight. So that'll then lead to increased variation in kernel size because you're mixing smaller kernels with larger kernels. The growing conditions can also impact that in terms of drought or the availability of water, fertilizer, and also the temperature, the degree of temperature that the grain is being exposed to, particularly during the heading and setting stage when the kernels are being filled. The variety has some impact on that, seeding rate and disease too. All of these things can lead to variability in bushel weight, but probably growing conditions like the droughts or the poor conditions that has led to the lighter weight barley that we've seen in recent years is the number one factor that will contribute to that variability. So then when we take that grain and we process it, the rolling settings are going to have an impact on that, whether you're using smooth or ribbed rollers, the degree of roller wear that's taken place on the rollers themselves, the degree of kernel uniformity, so the variability within the grain that you're processing, and then also the kernel structure, which is related to the protein matrix. We see those kinds of variations when we compare dent to flint corn, or when we compare soft to hard wheat, or when we compare hulled to hulless barley. All of those differences really represent changes in the protein matrix and the degree of affinity that the protein has for the starch within the endosperm of the grain. And when we set the rollers, then that degree of shatter that will take place will be affected, and the level of fine particles we'll end up with will be affected by the nature of that interaction between the protein and the starch within the endosperm cell. So how can we deal with that? Well, ultimately, as I mentioned, we can already use tempering. So if we add water to it, that gives us some degree of greater precision in terms of generating an optimal particle size, regardless of whether we're dealing with light or heavy barley. We can purchase grains with uniform kernel size. So that may be uniform heavy barley or uniform light barley. Either way, because the kernel size is set similar amongst all kernels within that lot of grain, then we can set the rollers to a single setting and optimally process the grain that's within that lot. If we can't do that, then what we can do is we can sieve the grain prior to processing it, where we separate the plump large kernels from the smaller kernels that haven't filled, and then we set two different roller settings in order to process the large kernels properly and to process the small kernels properly. That represents extra handling of the grain because you have to do the sieving process, but it's going to lead to more uniform particles after the processing, regardless of whether you're talking about light or heavy barley. And of course, when you do the mixed kernels, then with tempering, as I said, that can give you some of that degree of control to produce more uniform particles as well. So we did some work in that area. We were adjusting the dry rolling settings. So we were setting with multiple rolling settings. So we screened the mixed lot of grain prior to treatment and processed it through two different roller settings, depending upon the size of the kernels. And we compared that to a single rolling setting just to see what the value of doing that might be. It represents some degree of extra hassle, but what was the value of doing that? And when we looked at the starch digestibility, then when we used multiple roller settings, so this is in situ where we're incubating the grains in the rumen for set periods of time up to 48 hours, you can see particularly the 6-hour and 12-hour settings. By doing the multiple roller settings, we increased the amount of starch digestion that was taking place. And that's because with the multiple rolling settings, we're breaking the kernels and exposing that inner starch in both light and heavy barley. But with the single roller setting, we've got some kernels that are going through whole because it's not optimally set for the smallest kernels that are within that lot of barley. And so you see that then in the level of starch digestibility that we see at 3 and 12 hours as a result of adjusting. So you're capturing more starch by using the multiple rolling settings or settings that are specific for the large and the small kernels. And that's going to be then reflected by lower starch levels in the feces as well. So we know that barley kernels can come in a variety of different sizes. This just illustrates that when you have light versus heavyweight barley. And that can be both in the degree of plumpness as well as the length of the kernels as well. When we look at lighter barley, in terms of impacts on gain, this was some work that was done quite some time ago, back in the 80s, where they looked at just overall performance of light barley at 47 pounds, medium at 55, and heavy at 66. And you can see that the feed efficiency was lower for the overall light barley in terms of the amount of feed per unit of gain as compared to the medium and the heavy barley, which were fairly similar. And that really reflects the higher fiber content and reduced starch content that's associated with light barley. So we wanted to then look at how the kernel formative bushel weight processing and that affects the overall utilization of barley grains. So we selected light and heavy barley that differed in their chemical composition as well. And then we processed those through the system, either using either blending where we process them together as a mixture, or we process them and then process them separately so that we have a specific setting for the light barley and a specific setting for the heavy barley. And what that did then is, as you can see, when we look at the amount of exposure of surface area, so that exposed surface area is going to affect the amount of surface that's available for the microbes to attach to. So when we process the heavy barley, we increase that by 225% by processing it, 155% by light barley. If we treat the blend together, so that they're both rolled and then blended, we increase it by 180%. But if we rolled them together when they were as a mixture, we only increased it to 160%. So both the light barley and the barley mixture that was processed together results in less surface area for the bacteria to colonize in the rumen to carry out digestion. So this just shows the chemical composition then of the light and heavy barley. And you can see that the starch content of the light barley is lower than the heavy barley, and the NDF and ADF, which reflects the fiber content, is higher in the light barley than it is in the heavy barley. So the starch is the major energy source within the kernel because the bacteria can rapidly convert it to glucose into volatile fatty acids. So if we have less starch present in the kernels, we're going to have a lower energy content. And that contrasts with the fiber, which is particularly difficult to digest. Remember that a lot of that fiber is to resist insect attack or fungal attack when the grain is growing out in the field. And so that fiber has a very low digestibility. So if we increase the level of fiber by using light barley, we're going to lower the overall energy value of the diet. So these were finishing diets with 67% grain, where we either fed light barley or heavy barley, which is either processed before and then mixed, or processed after they were mixed. So this is just going back to those then. This is with the looking at both the dry matter disappearance, so disappearance or digestion of the entire kernel, as well as the digestion of the starch. And you can see with the low test weight or low bushel weight barley versus the high bushel weight barley, when we actually looked at if it was processed properly, we actually didn't see very much difference in dry matter disappearance between those two in terms of their digestibility. Uh, if we processed the improperly, there was some separation, but still not very extensive. Where we do see a huge difference is if the processing index is different. So if they were processed to 85, then the rate of starch digestion and dry matter digestion was slower than if they were processed to a processing index of 75. Remember, the lower the processing index, the more extensively processed is the grain. And then when you look at the composition of the diets, those also reflect then the differences in the starch and fiber content of the grains as well. So low bushel weight barley has higher NDF than high bushel weight barley, and low bushel weight barley has lower starch than high bushel weight barley. That didn't differ much in the blended materials. The blended materials represent a mixture of those high bushel and low bushel weight barleys. That also affect then the particle size. You can see that processing barley before resulted in more uniform particle size than if processing after they were mixed. If we process them properly, we end up with similar particle sizes between both light barley and heavy barley if they were processed to the proper degree. So the big differences that we see then in terms of basically animal performance is related to intake. So the dry matter intake of the light barley was higher than that of the heavy barley. Whereas and then within the processing barley, where we're properly processing each separately, we end up with higher intake than we do in the processing after as well. Those were the biggest differences that we see. So basically, the cattle are compensating for the lower energy value in the lightweight barley by eating more feed themselves. And when we looked at the digestibility, then the overall starch digestibility in terms of kilograms per day, more starch was digested with the high heavy bushel weight barley. That when it was processed properly for each of those fractions, then we end up with more digestible starch as well than if we are unable to properly process it because of the mixture. So again, reflecting increased energy availability with the high bushel weight barley or with barley that was in the mixture that was processed to the specific levels. So when you look at then the digestion, the pH was quite similar between both of them. It didn't tend to decline quite as rapidly with the lightweight barley. So that would just be a reflection of its lower starch content and higher fiber content. Again, starch is more rapidly digested in the rumen, so the acid production occurs more quickly, and as a result, the pH in this case doesn't decline as quickly because of the lower starch content of the lightweight barley. And this just showing the rumen pH, so you can see that the rumen pH in terms of the mean maximum, there wasn't a huge amount of difference across those various processing methods, regardless of whether it was light or heavy barley or the method of processing. So in conclusion, then, like the beef cattle compensate by having higher intake of lightweight barley compared to heavy barley, and we see a higher intake as well with properly processed as a result to inadequate process. And the same thing, we see higher digestion with a heavier barley compared to light barley, and higher with that which is properly processed. So processed barley increased both the digestible fiber and starch in the diet. So there's benefits to both improvements in starch and fiber digestion by better processing methods. Ruminal pH didn't differ very much. There was some level of reduction in the standard deviation in pH and with higher barley, and we do use that as an indicator of the risk of acidosis. So not surprisingly, if you've got more starch with the heavier barley, the risk of acidosis might be higher, particularly if you get into processing it too finely, which we could avoid by setting the proper roller settings. There was no difference in fiber digestion amongst treatments. So if you go through all the literature and the work we've done, I think can really aligns with what's been done previously, even back into the 80s. That you have to have pretty low bushel weight barley before you have a negative effect on the performance of the animals in feedlots because they can compensate through intake. Now that's going to differ a little bit depending upon the level of barley that's in the diet. If you had lower bushel weight barley, the more of that bushel weight barley you put in the diet, the greater the likelihood that you're going to have negative impacts on performance due to a reduction in the availability of starch and the associated energy that comes with it. But generally speaking, if you get anything less than or above 47 pounds or so, you're not going to have much difference, provided it's processed correctly. Below 47, you may have a possible 5% reduction in feed to grain with each pound of drop in bushel weight. But again, that's going to depend on the overall composition of the diet. How do we deal with low bushel weight barley in the future? Well, breeding varieties that are more drought tolerant would be one approach because drought is the number one factor that leads to lower bushel weight barley to begin with. We need to avoid blending lightweight and heavyweight barley together because that makes it more difficult to process, but that can be overcome by using the sieving, basically sieving out the light and heavyweight barley separately and then precision processing them in two different lots. We need to do further work to determine if the extra costs associated with doing that in terms of the handling of the grain in order to process in those two different manners, the implications that has on rate of production as well, in terms of keeping up with diet formulation to meet the needs within the feedlot would have to also be considered as well. So with that, that's kind of what I had as a summary. I'd be happy to answer any questions if there are some.
We can ask questions from him through the mic if you guys have any questions.
Yeah, thanks, Tim. Great presentation. If anybody has any questions, we can bring the mic to you. While I see some people thinking about questions, I might start with a question for you here, Tim. I was thinking about here, like, so if you have that light barley with lower starch and higher fiber, could you tweak your diets, finish your diets, then to maybe have less forages and then and feed that more barley to try to keep some of that performance and feed efficiency, or that doesn't really solve much of the problem?
Absolutely. I think that would be some of the adjustments that I was sort of alluding to there, Gabriel. So under those conditions, we add fiber to help maintain rumen function. So if you've got more fiber coming from the grain component of the diet, then theoretically we can lower the amount of fiber that we need to include in the diet that would be coming from hay or silage or other fiber sources. So that's also going to depend again on the processing of the grain. The critical thing, and I tried to emphasize, regardless of all of these challenges, the grain type or bushel weight or all, the most important thing is the level of processing and to make sure that they're processing to the extent that you're exposing that endosperm to digestion by the bacteria. But when it comes to that opportunity to formulate with higher fiber barley, yes, then you could definitely do that. And basically it sort of opens up the level you can push the grain in the diet in terms of deriving energy without experiencing acidosis because of that higher fiber content in the lightweight barley.
Thanks. Yeah, that makes a lot of sense. Any question? Okay.
I have two questions. The first is I thought it was common in drought years that protein is higher in barley, but you didn't see that with your studies. Is that true? And my second question is, hold on. Actually, answer that one first, and then I'll ask my one after.
Sure. No, that's right. So, the kernel, you got the entire kernel itself, which is composed of starch, mainly starch, fiber, and protein, right? So if you lower the amount of starch in the kernel, you automatically increase the amount of protein and fiber that's there. The amount of protein, though, will depend, a lot of that would come from the germ. And so the level of protein that might be present will be higher than if there was a lot of starch there. but it may be still curtailed by the drought conditions that with the fiber being less curtailed under those conditions, because with drought conditions, there tends to be more fiber deposited as well. But when you reduce the amount of starch, you're automatically going to increase the amount of other components that are present in the kernel.
Thank you. So my second question is, we've seen a lot of barley that's way lighter than what you looked at for light barley, like that 40 pounds per bushel. How much would that change based on what your research has shown?
Well, I think there you'd be getting into starch levels that were too low to be compensated for by just proper processing. So, one solution to that would be if you had that barley as well as other barley that was available that was heavier, you could look at processing those separately. I wouldn't recommend blending them together and then processing them, because then you won't be able to process each of them to their optimal level. Tempering may help deal with that. So if you have a tempering system, you might get away with that. But that would be one way of dealing with that, so that you get a blended final product that's got a higher bushel weight or higher starch content to avoid that reduction in performance you're likely to see. The last point I put there, where we sort of have a cutoff at 47 pounds per bushel, where below that, as you go down that, you lose efficiency. You would be in the area at 40 pounds where you'd be losing efficiency. Might be though, then you can also look, the other thing I didn't talk about very much is you can change the animal you're feeding that grain to. So if you were feeding that to cows for maintenance as part of your maintenance diet, that would be much less of an issue than if you're trying to feed feedlot cattle for finishing.
Yeah, Tim, just a follow up on that. Like I was going to ask about like one of the main issues is processing that light bushel weight barley, right? So it's really challenging sometimes if there's very low bushel weight to really tighten those rollers to be tight enough to process that lightweight barley. So you kind of comment on maybe like tempering if you can. A lot of times that's not possible. Is there anything else we could be thinking about? Or we never talk about like a hammer milling barley, but maybe this lightweight barley we could. Like, is there any thoughts on that?
Yeah, I think I'd still be a little leery about hammer milling barley for feedlot finishing diets, even the lightweight barley. But if you're talking for maintenance in cows or gestating heifers or that kind of thing, then I don't think there'd be any issue with that at all in terms of using hammer milling as a way of increasing the availability. When you talk about in feedlot diets, you ought to also think about mixing and blending and all of that kind of thing as well when you're formulating your TMR. So all that has to be taken into consideration.
Great. Yeah. Thanks. Any other question? Well, if there is no more questions, please join me in thanking Dr. McAllister. Thank you so much, Tim.
Thanks a lot, guys. Appreciate the opportunity. Enjoy the rest of your conference.
Thank you.